we go. So presenting with me today are Glen and Tim. Glen is leading the mechanical work stream, and Tim is one of our main authors for the 2.0 spec, and is leading the DCSCM 2 Type 1 effort, and he can talk about that more. So a quick glance at the agenda, a brief intro for those who are new to DCSCM, spec updates since our last talk in April, and areas that we're currently working on, and topics for future exploration. So DCSCM stands for Data Center Secure Control Module. So in January 2021, we formed a DCSCM 2 workstream under OCP. This is to create an environment for companies to have an open platform to collaborate and discuss and jointly define the 2.0 spec. So the goal to start the 2.0 is to support multi-node server systems and incorporating potential future manageability interfaces. So to do so, we introduced the LTPI for tunneling the low-speed interfaces, and Casper will talk about LTPI a little more later. So in 2022, with an increasing number of contributors joined the project and the rapid progress of the modular system architecture, the DCMHS. So DCSCM has gained popularity in the last year. So since April, we made significant progress on the mechanical requirements for DCSCM 2.0. And so for our current tasks are to close the definition of the vertical form factor for 2.1 spec, and then close the DCSCM 2 Type 1, DCSCI Type 1 definition. So this is to allow only a single function per pin and to improve compatibility. And Tim will touch on this later. Shows up. Okay, so now we have 16 companies working together to create the DCSCM 2 spec and collaterals, and these are the 16 companies. So for those who were present, give yourselves a pat on the back, because in July of this year, DCSCM 2.0 has been approved by the IC, and we're in the process of getting the final spec agreement signed. So the one that is signed, it will be official, available on the OCP website as a OCP specification. So on the right hand are the list of documents in this DCSCM 2 contribution collateral. There are two separate specifications, the base spec and the LTPI spec. And a new document was created as a result of the IC review process, a request from the security project, a security addendum that identifies the possible threat vectors of DCSCM modules. And many thanks to Paul Vinsel from Dell, who drafted this document when the request was made within a week's time. The other three documents are supplemental documents bundled under the DCSCM 2.0 spec. So if you go on our wiki, it'll show up as supplemental documents. But you can find all of these on our wiki right now, just as separate documents. So with that, I pass it to Glen to tell us a little more about the mechanicals.
All right. Gotcha. Okay. All right. Thank you, Qian. Appreciate it. My name's Glen Hanna. I'm a principal system architect at Lenovo. And we'll talk about the mechanical updates that have been made for the DCSCM 2.0 specification. So there's been some significant changes from Rev 1.0 to 2.0. We'll talk about those. You still have the horizontal form factor, both the external form factor, we call the EFF, and the internal form factor, the IFF. And then lastly, we'll talk about the scope for our next revisions. Those will be introducing the vertical form factor. We have both internal versions of a long and a short. So we'll talk about that. There's some different brackets that go along with those, some new connectors, and then just kind of briefly touch on some errata and any future additions that we may decide to put into the spec. Okay, so what changed between revision 1.0 to 2.0? Well, first off, we had a lot of improved 2D drawings here. So you can see an exploded view there. We have fully dimensioned drawings. They're nice and clear. We have a lot of clarity. You can see that everything's fully dimensioned with GD&T. Also, all of the keep out zones and the keep in volumes are all detailed and cross-hatched. So the intent was to be able to make, to be able to fully make a card from these drawings. Next is we wanted to make sure there was incompatibility between 1.0 and 2.0. And so we didn't want a customer to be able to plug a 2.0 into a 1.0 bay and vice versa. So what we ended up doing was taking the basic dimensions from I'll say the DCSCM 1.0 and kind of the TA1002 connector, and we shifted that card edge by 3.25 millimeters to the left. And what that does is when you put a wrong card in, it will basically have a hard stop on the connector. So you won't have any electrical connection there. We have bracket designs, fully dimensioned out bracket designs for both internal and external versions. They don't have the cutout, so you can customize it how you like. We have EMI fingerstock shields that are designed specifically for this, EMI fabric over foam gaskets, so you can have your choice of whether you want to have continuous fabric, if that's what your choice is, whatever your choice for your chassis is. Next are the rail designs. So we took the existing OCP V3 NIC and we modified it just slightly on the ends. It's still a reversible part, but in the DCSCM 2 spec, there was a situation where the screws that you mount to the bracket could actually be what's guiding the module into the bay, and we didn't want that to be the case. So we really want the card edges of the module themselves within tolerance to be the ones that guide everything into the bay. Come on up, Tim. Welcome. That's the external version. For the internal version, we have a new set. There's a mirrored set. It's a left and a right, and it basically has some additional features. And when you look at the boards there, I know it's a little hard to see, but there's additional notches towards the front of the board. And what that allows you to do is drop the module in, slide it rearward so that it engages with the motherboard connector, and then it's retained in place by those features in the plastic. So that's the difference between kind of the different rails there. And then lastly, all of the MCAD models are in step format. All of the rails, the bracket designs, the insulators, everything, fully dimensioned, CAD models there so that you can take those things, copy it, and just run with it, right? So let's talk about the HFF design. So firstly, the EFF, this is an exploded view. It has the board, the insulator, the bracket. You can see the different features on the bracket there for mounting, EMI suppression, those types of things. Note the BOM, kind of a generic BOM down at the bottom. But it also has features. You see the pull tab for insertion extraction, and also the captive fastener to retain it to the chassis. The internal version was really done with security in mind. It looks very similar, but you'll notice some components missing. There's no pull tab there, no captive fastener from the outside. This is really meant to have everything come in from the inside of the chassis and expose it outward, all the connections outward, without having anything to be able to pull it out externally. Okay. So as we look forward for the next dot revisions, there's a few things there. So we'll be introducing the vertical form factor again, improved. It's a little different. It's greater than 1U, so it's really meant to go in a 2U type chassis vertically, of course. There are two different versions. There's a long version, which you can see is the top image there, the The bottom image is the short version. There's a difference of about 58 millimeters or so. But really what it does is allow you to add some personality to the module. There's a lot more real estate there, so you can put other things. It does have the same DCI pinout, so you don't have to worry about that. There are 2 bracket types for the rear chassis flanges here. You can see type 1 and type 2 on the bottom there. Basically the difference is the flange, right? So some people may want that flange pointing internally so that they can put the card in and have it screwed in horizontally from the external surface of the chassis, or have it come down much like a half height, half length card goes down and you retain it much like you would a PCI card. One thing to note, these brackets are wider than a low profile card, so it's not gonna go in the same slot. You don't have to worry about that, right? The next one is a new connector that we designed for DCSCM2. It's a dual stack type A USB connector, but it's optimized to be a low profile connector. I've got one of these here. It's fully tooled. It's not in the 1.0 spec, but it is something that we're looking to make available to people, for people who want to have 2 type A ports on that module. As you know, it's quite compact there, and all that real estate's very important. So being able to cram these types of things, in that vertical space of 15 or so millimeters is really critical. It does require some modified brackets. So when you look at the brackets, you see the EMI fingers across the top, the bottom, the sides. It does have to break through the bracket, and so instead of 9 fingers across, you're going to have maybe 4 and 4 or 3 and 5, depending on where you need your USB connectors to be relative to the edge there. And then lastly, any errors in the document and stuff, that's certainly stuff that we'll correct. Any kind of feature adds or even some examples that we see out there to say, hey, look, this is kind of what's happening out there, might give you some ideas about how you may want to implement that. Okay, so that's pretty much the mechanical section. I'll go ahead and pass it over to Tim. And Tim will talk about the design spec for the Type 1 version.
Thank you. Hi. DCSCM is a card electromechanical spec. With it comes interfaces that pins that have 2 or more functions per pin, and there's no guarantee of not requiring hardware co-design between the HPM, host processor module, and the SCM by nature. Many of the examples you see out on the floor probably needed co-design with the HPM because it's not defined to the nth degree. So this is an effort that the work stream started. Qian allowed us to take over the work group when we were done with the 2.0 to start. OCP's never really done good design specs at all. And this is our attempt to say, there's things in a host processor module that allows us to do silicon diversity and is the core competency of the CPU vendor, for example, or whatever product you're trying to produce. However, there's a lot of miscellaneous stuff, predominantly what traverses through the SCI, that should probably be commoditizable so you can guarantee hardware interop. You have 2 types of use cases. One, I have systems and I want to replace the SCM because I may have a different root of trust. I may want vendor compatibility. I may have a supply continuity issue and needed to do something like that. And then in other cases, you want HPMs to drop in with reuse your same SCM across your entire portfolio. My company, we do about 50 platforms per generation, so it's very important to us to be able to get those HPMs and not have a heavy touch every time. So this is our attempt to try to say you get 1 pin, 1 function per pin. This is the exact use case, and this is the exact topology, and these are the electrical parameters of electrical loss on the side of the connector A and B, that sort of thing. So we can achieve those sorts of goals. And it's actually going surprisingly well. We're very close to getting agreements on the 1 function per pin. We understand that you can use a subset of that, but we define type 1 to be, okay, well, what's the biggest chunk of the market where this makes a sense? A 1 to 4 socket server, not necessarily a network switch or an accelerator tray specific box. That's not really even a host processor domain. So we're trying to say, okay, for this biggest swath of the market, can we define and say this is what a type 1 is? We understand a type 2. We're setting up the way you do a design spec, which dictates what will be on the HPM and the exact use cases of how you're using the interfaces themselves. That's kind of the whole point of it. And then beyond that, there are implementation specs where our goal is to get to the point where the implementation specs reach the point of what we call plug and code. You're only changing bits, your own signed bits, but you're not having to go and change silk screen, any aspects of that HPM board to do the productization, beside even though, whether you come through your supply chain or you think you can achieve the nirvana of true off-the-shelf HPMs. I think that's pretty much everything on this one. Sorry. So we're looking at futures. Definitely welcome people's feedback. This conference has been great and getting a lot of people's opinions. There's an internal form factor. Glen talked about, well, it's really an external connector with a blank faceplate. That's a little bit different than, I really want maybe a mini SCM with the ability to extend and customize the I/O, but still reuse this piece of the subsystem and leverage the layout and the security aspects and all the bits and reuse of your printed wired assembly and your bill of materials and whatnot. So there may be mini, there's extensions, mezzes, attic cards that may extend things that weren't in the SCI that you might want to do what we call fly over the HPM or provide other internal facing things. Or there's a lot of different, especially edge type applications where the system is just so crunched down. You saw the vertical form factor that Glen showed. There was 2 because of different depths of the chassis. Horizontal really has one depth. It is what it is. So we think we need to start working in things of that nature. We want to keep pressure testing the applications. What do you see that we could make better? We're also trying to lower the barrier to entry, meaning different types of, there's some challenging things when you're designing the isolation circuitry and things of that and the discovery sequence and how you go through the boot flow. My spec for my company is about 35 pages of how do you get through the boot flow. The boot flow for happy and sad path, all cases. So it's can be daunting to do something that you think you're just going to walk on this floor and plug and play. So we're trying to lower the barrier to entry, maximize the adoption, provide other variations of this thing, maybe different external connector commoditization. There's probably 10 SCMs out on that floor. And all of them are remarkably close, and the types of I/O that's actually leaving the thing. So we're basically debating, is there a way to even commoditize those pieces of it if it makes sense. So rear interchangeable I/O. You may want a 1 gig dedicated NIC. You may want analog video. You may want DP. You may want HDMI. You may want USB Type-C. You may want the double stack Glen just showed. I don't know. So it's a lot of variations there that are just, you may want your color blue LED. I don't know, a lot of different stuff there. Multi-node management is here and coming stronger and stronger every day. There's challenges with multi-node management, not just, hey, can we duplicate every single interface twice and we're done? It's not really quite that simple. So how do you support the fan out? There's a lot of challenges when you talk about multi-node with multi-tenancy, meaning every HPM that couples with that HPM that you're managing, you need this for security isolation. So that's kind of the nirvana of multi-node, includes multi-tenancy. But first pass, what's in the spec right now really kind of hand waves through some of that and is really around just the multi-node with trade-offs. There's certain concessions that were made, so we're definitely needing to really take more seriously multi-node management and not just stopping at 2. Maybe more, but 2 would be a big win for a lot of people. Chassis management applications is another one. The open RMC, what other kinds of things can you do in this domain? Other types of subsystems you can put in there. And then these, I already talked about the internal only apps that have a lot of interesting and evolving use cases and rationale for that. But still what we really are committed to is continuing the SCI. A lot of wins to make the SCI is what it is today. 3 to 4 attempts to do this in the past 15 years have failed because we couldn't come to terms with the SCI. leveraging interfaces like LTBI to be able to tunnel a lot of things. There's literally one GPIO I think we have left. That's a big win for us in terms of the customizability of being able to virtualize wires and I/O and actually make this thing usable and reusable and over across gen and agnostic of the CPU architecture and agnostic of the generation. There's a lot of future proofing in there. Gen 4, PCIe by 4, I'm sorry, Gen 5. So there's a few things in there that we're always looking for pressure tested feedback. I think it's pretty easy to join. Chen can help you join. This went from 2 companies to 16 or 17 companies, and weekly meetings, and always, we're right at now's the perfect time for collecting requirements for the next evolution of this, so we can actually lower the barrier to entry, make it easier to go to market, make you more confident in hardware interop is absolutely our goal, and making it not you needing a PhD every time to go through the process. And ultimately getting to plug and play. People think that's just a joke. You're never going to accomplish it, but at least to the point of plug and code, meaning I didn't touch a trace, I didn't touch anything with the Gerber files, anything like that, but I can lay my bits down, do my mutual authentication, load my FPGA image, whatever it is. But there's a lot of pressure too there is how do you commoditize the things you're doing through these interfaces like the LTPI. There's a lot of real-time and a lot of non-real-time functions that traverse through these interfaces, very much quite custom at the moment. And we're trying to figure out how to self-describe attributes and capabilities so that you can adapt, your BMC firmware can adapt to what it is it's finding and route the right bit in the right location, that kind of thing. I think that was it. So join, did you want to close out, Chen? Okay, provide feedback. What do you like? We have hard skin, we love feedback. What do you hate about it? There's a pretty good group. Weekly meetings, there's a monthly public if you didn't sign the contributor license agreement, just to keep tabs with what's going on with the spec. There's a wiki site where things are kept up to date. It is, what's released on the spec today is release candidate, I still believe. There's still some legalities of the IP agreements and stuff for getting, because the community has gotten so big, that's a blessing and a curse to getting through, all the legalities and the signatures. But yeah, it's perfect time for the design spec piece and the evolution of what we want the base spec, hard electromechanical, new variations and that kind of thing. Do you have questions?
Okay. Yeah, we have about 8 minutes, so
We have a few
we can
minutes.
take questions. if there are any.
There's one thing I forgot to mention. So on the wiki site, we have a spreadsheet that keeps track of topics and discussions, some of them. So there's a new tab. It's called a wish list. So if you want to see anything you want to see from DCSCM, please just feel free to enter that topic into that wish list, and we'll try to incorporate that in our next revision.
And there's a reflector email as well, I believe. Isn't there, I think there's is there not? Anyway, sorry.
Oh, there's a mailing list, you mean?
Yeah, mailing list.
Yeah.
There's mailing lists to get, any questions or feedback. There's a mailing list. I think our names are on the documents. We're easy to find. We're committed to answering and not letting feedback go into a black hole and having closed loop on public feedback, anyone's feedback, and trying to make this thing a success. So.
Okay. Are there any other questions? If so, we have 2 microphones you can come up to. So if not, I have a question. You mentioned chassis management. So how would DCSCM need to change to support chassis management?
I've done a few chassis management controllers in my tenure. There's generic interfaces, PCIe, USB, different types of fan-out things you can do there. LTPI is an abstraction layer that allows you to do all kinds of fan-out for multi-node. We're definitely very interested in, there was a session earlier about a lot of the multi-node evolution that's getting kicked in by CXL and other types of use cases. So yeah, we need to figure out whether the interfaces and how those things branch out, and what we're actually trying to accomplish. Yeah, there's an effort kicking off called SIF, Shared Infrastructure, under the modularity umbrella, that is absolutely focused on this, and a lot of different satellite multi-HPM sort of situations that we were very glad to get 2.0, whole and ready to go. And now it's time to take it into upper gear and start looking about these types of exotic use cases. And, we want everyone's feedback, so.
Okay, thank you. So if there are no more questions, we can close this session and we'll wait until, yeah.
Thank you.